So last week, grade 10s, we started just talking about factoring trinomials, in which we talked about you have to find two numbers that multiply to C, so that's a product, a sum of B. This is what we were talking about last week. Do we remember this? Yeah? We did this on Friday. My OE kids, I really hope you listen to those videos. Good. The video I posted and emailed you about. That's basically what today's class is. It's just more practice. So when we're factoring, we want to find two numbers that multiply to our C term or the last term and add to the middle term. Brady, your book should be open by now. You've been sitting here the whole time. Let's get moving, please. So on this first example, if we're factoring x squared plus 6x, Carissa, did I share this? Are you even looking at anything? Sorry. I didn't share my screen. My apologies. Okay, there we go. So in the first example, x squared plus 6x plus 9, we need to find two numbers whose product, so that's multiplication, is 9, and sum is 6. So what are two numbers that multiply to 9 but add to 6? 3 and 3. So that means the factored form of this guy would be x plus 3 times x plus 3. Because 3 times 3 equals 9, 3 plus 3 equals 6. That's all you would do on these questions. So this next one, x squared plus x minus 12. So we need a product that's minus 12 and a sum of 1. Remember, when there's not a number, there's like a hidden number 1. So what are two numbers that multiply to equal a negative 12 but add to equal 1? Anyone? Two numbers that multiply to 12, add to 1. What are the factors of 12? How could I multiply to be 12? So if you don't know, go back and write your factors out. So I can do 1 times 12. Good. So 2 times 6, 3 and 4. So what I do is I would list them out if I'm really stuck. Okay, and then I'd be like, what are my differences? So the difference between 1 and 12 is 11. Difference between 6 and 4 is 4. Difference between 3 and 4 is 1. So I say difference because it was a negative 12, right? So one of them has to be a negative. So 3 and 4 have a difference of 1. It needs to be positive 1. So that means the 4 has to be positive and the 3 is a negative. So our answer on this question would be x plus 4 times x minus 3. Could I write it the other way? So x minus 3 times x plus 4? Totally, doesn't matter. Okay, let's do some examples. Do you need a second? Go ahead. Yes, very much, because if we said negative 4 times a positive 3, it'd be a negative 1. So it very much matters. Okay, so this first example here, we have x squared minus x plus 12. So that's exactly what Hafsa was getting at. So in this one, very similar to the question we just did, but now it's a minus x. So I need, you don't have to show this step, but it's a good prompt for those of you that struggle with like your number sense. I need two numbers that multiply to negative 12, but add to negative 1. So like in the last example, we're going to use 3 and 4. Which one's positive though now? Which one's positive? So 3 is positive and my 4 is negative because that gives me the negative 1 here. So my answer is going to be x plus 3 times x minus 4. Or I really want to stress with you guys, the order doesn't matter. So I could also write it like this. Both of those are equally correct. Can you guys see the board well enough with the window? Yeah, okay. It's just a lot of glare for me when I look at it. Okay, so this next question. Two numbers that multiply to equal a negative 18 and add to equal 3. So with a question like this, One of them has to be negative, right? The only way I can get a negative product is with one of them being negative. Another prompt that might be helpful is to label one negative initially. So what are my factors of 18? 3 and 6, 2 and 9, 18 and 1. We always forget that one too. 3 and 6 gives me a difference of 3. Which one's positive and which one's negative? Good. So I get positive 6 with a negative 3. Negative 3 plus 6 gives me my positive 3. So your answer on this one is going to be x plus 6 times x minus 3. You only have to show your answer. You don't have, like, this is bonus work. But writing that out can be really helpful. Okay, this next one, I need two numbers that multiply to be negative 8. So if you don't want to write it that way, another strategy is to make like a little table. So my multiplication and then the addition. So 8, I could do 8 and 1, 2 and 4. One of them is going to be negative. So I would say instead of addition, maybe write difference here, because in this case, it's going to be a difference. The difference between 8 and 1 is 7. Difference between 2 and 4 is only 2. So that tells us we need to use this first row. Which one's positive, which one's negative? Go ahead, Matt. Good. Negative 8 plus 1 equals our negative 7. Negative 8 times 1 gives us our negative 8. How is this? Okay, let's pause for a second. Up at the very top of the page, there's kind of space, I believe, right here, like on the side. On the left side, is there kind of space here? A little bit, like a little column like that. It's sideways. Oh, okay. How about right here? Do you have space? Right here, do you have space? Okay, make a box similar to mine. We're going to make some comment notes to help us remember. So when factoring, these are always our pieces. Very first thing you should think about is a GCF, greatest common factor. This is when your A term, so like, because it's AX squared, so when the A is not 1. We're going to do an example of that later on. So for example, if you have a trinomial where it's like 2x squared plus 4x plus 8, when this term is not 1, then you always first see if there's a GCF. There might not be, but that's your first reaction, is to see if you can factor out that term. Then your second piece, you need two numbers that multiply to see the same two numbers add to B. Point 3 is check your signs. And say maybe check for negatives. Throughout this unit, we're going to keep adding to this list. We're going to tweak it and add different pieces to it, but we're going to do a little summary chart like this often throughout this unit. There's a lot of different pieces within this unit, and so this is kind of helpful to like check in. Okay, so the next class example 2, so the next 4 questions, we're going to keep this in mind. Okay, so let's go here. So on our first example, our A terms, there's not, right here is like the number 1. So that means there's no GCF here. Can't factor it out. Great, moving on. So now I need two numbers that multiply to 27 and add to 6. 27 has a few factors. 3 and 9, beautiful. Positives or negatives? Go where? Which one? So we're going to get a plus 9 and a minus 3. 9 minus 3 gives us a positive 6. 9 times minus 3 gives us our negative 27. Do you see how important it is doing your multiplication tables right now? And to be good with integers? Like, shockingly important. Is this concept overall that hard? No, I could tell my grade 7s to be like, can you find 2 numbers that multiply to 27 and add to 6? With enough time, they could probably figure it out. Do they understand any context here? No. But that piece isn't actually that hard. But what gets hard is you get frustrated, right? Like if you have question after question where you're struggling to come up with factors, that gets really frustrating. And then you get negative on yourself, and suddenly this unit becomes much harder than it is. Does that make sense there? Yeah? Can I zoom in now? You guys all caught up? You're not caught up, Andy? Okay. So why aren't you writing? We can come back? Yeah? Oh, it's not there. My apologies. Okay, so question 2, there is a number in front of my squared term. So our first reaction is always should be, is there a greatest common factor? Yes, there's a 2. So first thing we have to do is factor out a 2. So this was like lesson 1 of this unit. I'm going to factor out a 2. Leaves me with t squared minus 7t plus 10. Does that make sense how I got out that 2? Right? If I multiply it back in, am I back at the original question? Good. Now we need 2 numbers that multiply to 10 and add to 7. Sorry, add to negative 7. So my answer is a positive, but my addition statement is a negative. So that means both numbers are negatives. Okay, so on this one, I would write it out. Sometimes this is another little strategy. It's going to be x minus something times x minus something. Sorry, t, yes, thank you. T minus something and t minus something. 10, my only factors are 1 and 10. That difference is 9. Or, go ahead, Wyatt. 5 and 2. 5 and 2. So minus 5 and minus 2 gives me a bigger negative number of minus 7. 5 times 2 gives us our 10. Okay. C, 2 numbers that multiply to 6, negative 6, and add to equal negative 3. What are my multiples of 6? 1 and 6, good, and 3 and 2. Do either of those work? No. Did we miss any multiples? Sorry, did we miss any factors, I should say? No. And then that just means it's not possible. So then you say it's not factorable. Not factorable is your answer. Do not leave it blank. If you leave it blank, I don't know if you skipped it, if you recognized it. You have to say not factorable. Okay, let's look at D. Is there, this first term is not a 1. So there's a GCF. What is your GCF here? 4x squared. I can factor an x squared out of each term. Always take out your greatest common factor. That's going to make your life so much easier. So when I do that, I factor out 4x squared. My first term, I'm left with an x squared. Second term, I'm left with 4x. Last term, 5. 2 numbers that multiply to 5 and add to 4. My final answer is negative. So I know when I look at my brackets, I'm going to have x minus something and then an x plus something. Overall, I need a negative sum from my adding my 2, so my bigger number is going to be more negative. What are the only factors of 5? 1 and 5, so it's going to be a -5 and a +1. -5 plus 1 gives us -4. -5 times 1 gives us -5. Okay, let's turn the page. That's basically a review from last class. So especially for those kids who weren't here last week, that should be really helpful. So now we're going to look at ones slightly more complicated. So our original formula, they tell us now we're looking at questions like this. So now our questions have a y term as well as our x terms. Now we're at 2 variables. This sounds scarier than it is. So they give us this first question where it's like x plus 2 times x plus 4 is expanded to this. Do you guys agree? If I was to actually write this out, I'm going to write it out to the side. I'm just doing FOIL. This is your check throughout this whole unit. I get x times x gives us x squared. X times 4 is 4x. 2 times x is 2x. And then my last terms plus 8. I add up my middle 2 to give me 6 plus 8. Okay, so that's where those factors came from. So x plus 2, x plus 4. They then are changing it to be x plus 2y times x plus 4y. How does that change things? So let's go through FOIL on this one. So x plus 2y times x plus 4y. X times x is still x squared. X times 4y gives me 4xy. 2y times x gives me 2xy, and then my last term becomes 8y squared. So it's the same idea, just with an extra variable. So just completing their sentence, which basically I did to the right, but just so we fill in all the blanks, this is x squared plus 6xy plus 8y squared. So adding these two gives us our 6xy. So what that means in reverse, x squared plus 6xy plus 8y squared can be factored to x plus 2y and x plus 4y. That is like the world's most redundant way of saying this. Okay, so let's try some of these examples. So this first question, do I have any GCFs? No, great. What I would start off doing on questions, we're still finding two numbers that multiply to 30 and add to 13. The only catch now is I know our answer is going to be x plus something with a y. And then x plus something with a y. I know that because my last term is a y squared and there's a y here. So there has to be y's on those two. So we're still doing the same process, just with an extra variable. 30 has a lot of multiples. All of these are positives because my middle term and my last term are both positives. So what different ways can I get to 30?
I looked at the, see what adds to it, or I guess can see what you can add to 13. So I just kind of also saw 10.
Good. So you're totally right. So when I see 30, my first reaction, and I don't know about you guys, is 2 and 15. 2 and 15 added together gives me 17. Not helpful. So then, like Tim said, he went to 3 and 10. What's helpful when you're listing out your factors is to go up by one of them. So we went from a 2 to a 3. My next one, 4 doesn't go into 30, but 5 does. So it'd be 5 and 6. So notice that this side is increasing, and this side, that's going down though. But like, look at the order, right? Like this way my numbers are getting bigger. This order, my numbers are getting smaller. That's going to help you not miss any potential multiples. So 10 and 3, does it matter where the 10 or the 3 goes? No, because they're both positives. 10 plus 3 is 13. 10 times 3 is 30. Okay, my next one. We have that pesky y again. So I know I'm going to have x with y's on my end. Let's think about our signs now. This is a negative sign, but this is a positive sign. So that means one of these is going to be a plus, and one of those is going to be a minus. I also sometimes find it really helpful to draw out like my template like this. Multiples of 72. The first one I always go to would be 8 and 9. Okay, 71 is my middle number. That's a really big number. 8 plus 9 is nowhere close to that. That should be our other prompt that we're going to have 1 and 72. Right? To add to 71, we need a big number for our factors. That's going to be our biggest. It was a positive 71. So what that means is it's a positive 72 and a negative 1y. Do you need to write a 1? No, you could just say x minus y. What's our first thought on this one? Good. So we're first going to factor out a 3. So I get a squared minus 5ab minus 84. Do you guys remember how to do long division? Nope. Let's review that real quick. You don't get a calculator for this test. I think you're all capable to do the division of 352 divided by 3, but let's just review it. So I go 3 on the outside, 252 on the inside. 3 doesn't go into 2, so I write an x. How many 3's in 25? 8. 8 times 3 is 24. Then you subtract. That's a difference of 1. Bring down my 2. How many 3's in 12? 4. 4 times 3 is 12. I subtract, I get a 0. So our answer is 84. We're not going to give you decimals. So likely you've made a mistake if there's a decimal. We're not going to give you decimals. I'm not going to do that to you. I shouldn't say likely. Okay, now I need two numbers that multiply to 84 and add to 3. 84 is a big number. 84 doesn't go into 5. That should be your first reaction, right? 5s are pretty easy to go big, same with 10s. What goes into 84 that you know off the top of your head? 84 and 1, okay. Okay, so sorry. 1 and 84, 2 and 42.
24 or 21.
Okay. But none of those work. 84 is even. What's the number? Tim. You're not Tim. No.
7 and 12.
Good. If 12 goes into it, does that mean 6 goes into it? Yes. So it also would have been, right, if we have 7 and 12, which is our answer, that also means 6 is going to go into it with double that. So 6 and 24. 7 and 12. So we get A, this is a B, A, this is a B. 7 and 12. Which one's positive and which one's negative? I have to fill that in with a 7 and a 12. I need negative 5. Good. 7b and minus 12. Because positive 7 minus 12 gives us our negative 5. 7 times minus 12 gives us our negative 84.
Will we be getting this low from numbers on the actual test?
Yes, you should know your 12 times tables.
So if we factored out a greater factor, in the final thing, we can divide out the greatest cost factor before.
Yes, it should be. I did. Right there. It should be first, like on the 4x squared one. Yeah.
Like, only with like one variable, like two.
Yep. Yep. Right there. Okay. Lovely. So that's it for today. Last class I assigned some questions. If you didn't finish them, finish those first. Today's are slightly more difficult. So do the ones first. Then these ones are for today. Yes, Andy. That's totally fine. Yeah. We're going to have, so this week your class is ahead of my other section. So today we're going to have a learning class, and then our next 2 classes are going to be work periods. So that's why. I have to work on these questions. So today you can work on them, but then I have other activities we're going to do as well. That's going to be some practice. Yes, Cam.
Does one of those activities include a Kahoot?
Kahoot? Kahoot is really hard because
Just take manual questions?
no, I could do a Kahoot, but what makes it hard is I don't like that it's so timed, and then people who are a little bit slower end up just guessing. I know, but regardless, people who are a little bit slower then don't. It's not a boost to their confidence when everyone's waiting on them.
Oh, I don't have pups already.
Yeah, exactly.
Give us like 5 minutes.
Yeah.